This is a video for AQA Further Pure Mathematics. The sequences series section 1.2, and we're looking at the formula for the sum of the first n integers. Now that formula using sigma notation is written as the sum from r equals 1 to n of r. So for different values of n equal to 1, we get the sum just being equal to 1. When n's equal to 2, we get 1 plus 2, in other words the first two integers added together, giving us a sum of 3. N equal to 3, 1 plus 2 plus 3 equal to 6, and so on. Now that sequence of numbers 1, 3, 6, 10, 15 you may recognize as being the triangle numbers, are so called because we can draw the pattern in a triangle form, 1 and then 2 on the next line, 3 on the next line, and so on, 4 on the next line. So we get a pattern in a triangle. Now if to that pattern we add another one, but this time upside down, we get, you'll see there, a rectangle, and that allows us to work out a formula for the sum of the first n integers. Let's see what we've got here. We have in our rectangle, the one side of the rectangle is going to be n, and the other side of the triangle has got n here, but also then an extra 1 at the end, so n plus 1. So the rectangle has got size n multiplied by n plus 1. But this is twice the sum, so therefore we can see that the sum from r equals 1 to n, so the first n integers, is equal to 1/2 of this, a half n plus 1. Now this is not a rigorous proof, however it is the correct formula, and so there we are, written out nice and neatly for you. The sum is equal to n plus 1 over 2, or a half n plus 1. We can use this then to do some sums. Here we've got the sum of the first 100 integers, so this is 1 plus 2 plus 3, all the way up to plus 100. But we don't need to do the sum now. We can use the formula which says that this sum will be equal to r, which is 100, multiplied by r plus 1, so 101, beg your pardon, n and n plus 1, and then divided by 2. So that gives you a total of 5,050. Now a slightly more complex situation. This time we've got 3r. So remember, this is 3 multiplied by 1 plus 3 multiplied by 2, etc., all the way up to, in this particular case, 3 multiplied by 16. So this is the same as, we can factor out 3 multiplied by 1 plus 2 plus all the way up to 16. So what I'm trying to show you there is that we can write this sum as being 3 multiplied by the sum from r equals 1 to 16 of r. In other words, the 3 can be factored outside the summation. Well, once we've decided that is true, then we can use our formula which says that it will be 3 multiplied by, and then we've got n, which is 16, multiplied by n plus 1, which is 17, divided by 2. And if you calculate that, you get a total of 408. Well, that's the end of this video on the sum of integers. In the next video we'll be looking at the sum of the squares and the sum of the cubes of the integers, so sigma r squared and sigma r cubed.